Good evening, all. Can you hear me?
Yes, sir. Good evening.
Okay, good evening. So last Tech Talk we discussed about the design principles of the final lining, and it was mostly focused on the cast into concrete lining. But we this same the topic we'll discuss about this the TBM machine and the principles of the precast segment design. Now, how much people have experience working in TBM? Can you please tell me?
I have.
Sir, I have worked.
I don't have any experience till now.
Okay. Okay. Any other one?
Sir, I have worked.
Okay. The difference between a conventional tunneling and the TBM tunneling is that TBM tunneling is a mechanized tunneling. In conventional tunneling, what you are doing, we are making an excavation either by drill and blasting, then either by mechanical excavation, and then you are making installing the supports. It is two type of support. It's a primary support, then it is a final support, and it there are all other intermediate activities also. So it's a very slow process, and it's a very lengthy process also. So if you take the progress wise of a TBM and a conventional tunneling in very competent rock, in 1 meter you can reach up to 2 meter, 2.5 meter per day. But if it is a very favorable ground for the TBM, you can reach 20 meters, sometimes 25 meters per day. And it is a since it is a mechanical excavation, so here the excavation and the support installation both are done simultaneously. And in TBM tunneling, there is no conception of primary support, so only it is the final support. So in NATM tunneling or in a conventional tunneling, what you are doing, we are first installing the primary support to stabilize the excavation or stabilize the opening. And once the opening is stabilized, then we are installing final support that is going to take the loads for the next 100 years of the design life. So the TBM tunneling is more advanced process of the excavation, more advanced process of the support installation, and more advanced also in terms of waterproofing or any other things. If you talk about the serviceability, if you talk of the durability, everything is very advanced. Now, for the TBM machines, there are two type of TBM machines. One is used in the rock, another is in the soft ground. So soft ground can be silt, it can be clay, it can be mix of silt and clay, it can be sand also. So if it is a rock TBM, there are two types of TBM. One is called open TBM, another is called shielded TBM. Open TBM means the rock is very hard, very competent rock. So you do not need any face pressure because when the TBM is moving, there is a always a ground ahead of its space. So the ground, if it is a very soft, it will try to move towards the TBM because of the pressure difference. Because TBM is a very highly pressurized machine. So open TBM means that the face is so competent or the rock is so competent, you do not need any type of thrust or you do not need to any type of face pressure for the TBM because the face is stable. So here we can use the open TBM. If it is a very not competent ground, if it is a mix between a hard ground or weak ground, or if it is a some types of very soft ground, we use a shielded TBM. Now, shielded TBM, there are two types of TBM. One is called double shield TBM, one is called single shield TBM. Double shield means it has two types of shield. One shield, when the TBM is moving, one shield is working and another shield is trying to build the segment. So what is happening that TBM, when it is moving, it tries to take the thrust from the segments. In all type of EPB machine you have used in metro projects, every EPB machine, whenever it is moving, it is taking the thrust from the segments. That is the whatever the segment it has been installed. From the segment, it is putting its jacking, ram pads, and then it is moving. So it is just type of one type of we can take as a movement of a grasshopper because you see the grasshopper, it is trying to push itself when it all by all its legs. The same the TBM is pushing by giving the thrust to the tibium and then it is going ahead. So if it is a single shell tibium, the problem is the single shell tibium, it cannot take the thrust from the rock because it's a so competent ground. So it tries to take the thrust from the segment. So one time it is building the ring and another time it is building the excavating. So excavation and the ring installation, it is done by the single shield. So its progress is very slow compared to a double shield because in a double shield, the both shields are independent. So one shield is excavating, another shield is helping in the ring building. Now, It can be if it is a it can be groundwater condition, it can be a low groundwater condition. So accordingly, we decide that what type of field we'll use. Now, if I go to the shop ground sealed machine, there are two types of machine. One is called earth pressure balance machine. Another is called slurry or hydro sealed machine. Now, earth pressure balance machine, the concept is that whatever the earth it is excavating or whatever the ground mass it is excavating, it is stored temporarily in the excavation chamber. In the excavation chamber, it can be full or it can be half, it can be quarter, it can be 3/4, depending on the pressure that is the TBM is giving to the ground or the pressure that the TBM face is expecting from the ground. So depending on the ground condition or the face pressure or the you can take that sometimes if the ground is very shallow or sometimes there is a water condition that is water ingress from the ground to the TBM. So depending on that, the excavation chamber can be removed. Some part of the excavated material can be removed, or some part of the excavation material can be provided. So it's a balancing of the earth pressure. So the by from the excavated material, the machine itself is trying to stabilize the face ahead of it. Now it can happen that the excavated material is very has a very low specific gravity or very bulky and it cannot apply the sufficient thrust that is expected from the ground. So that time you are using some types of additives or some sort of polymers to make the excavated material some sort of heavier specific gravity. Now the slurry machine, it basically uses a slurry. It can be a bentonite slurry, it can be a foam, it can be a polymer to stabilize the face ahead of it. And slurry machine is only applicable to sand or you can take a highly permeable soil where we cannot expect that the ground will be stable because in artificial balance machine we expect that the ground can be stable some sort of by some sort of means because we can apply a minimum phase pressure or it can be some sort of bentonite we can apply but in slurry or hydroseal is only applicable when the stratum we are working it is a highly permeable ground or the groundwater condition is very high or it's a very permeable ground so the ground can be flowing. In that condition, what we are doing, there is a slurry chamber inside this machine, and from that slurry tank, the slurry is going to apply a thrust on the ground ahead of the TBM, and it forms a mud cake. Basically, it forms a mud cake, or whoever people who have worked in that, if you have worked in the diaphragm one, you can see when we are excavating the trench, we are putting a bentonite slurry. So what is the bentonite slurry doing? Bentonite slurry basically forming a mud cake inside the in the trench, and it applies a thrust, so the trench is stable. The same concept the slurry machine is doing, and the slurry machine is keeping ahead of its space stable. Nowadays, what happens that there are several regions where the ground is not purely clay or not purely sand. Sometimes it can be a mixture of sand and clay. Sometimes it can be a mixture of very weak rock and soil also. Because in Chennai, in Bangalore, we have encountered frequent stratums where the ground is mixed. So it can be seen that the above the spring line we get a very hard rock condition, and above below the spring line sometimes you get a very soft ground condition. So in that case, what happens is sometimes EPB can work or sometimes slurry machine can work, or it can be a mixed combination of both machine. So if I get such a ground stratum where EPB cannot work for a certain particular region, then I cannot stop the TBM because if I just stop the TBM, then automatically the phase pressure will drop ahead of the ground and it will create a settlement. So what we are doing currently, we are using a hybrid EPB machine or hybrid EPB slurry machine. So EPB slurry hybrid machine means that depending on the ground scenario, the machine can switch from a hybrid EPB mode to slurry mode or slurry mode to EPB mode. Sometimes it can be switched from EPB mode to open mode also or open mode to EPB mode also. So depending on the ground scenario, depending on the geological log or along your alignment, whatever the geological section the geologist or geotechnical team had predicted, so depending on that, you can select your perfect hybrid EPP machine. But hybrid EPP machines are since very costly, so sometimes the client or the contractor does not prefer. But in certain regions or certain, suppose in Chennai or in Bangalore also, currently in Bangalore, there is a big road tunnel coming on that is being built by Adani. So there people are thinking of going slurry machine, but with EPB mode or in a rock mode also, because if I encounter a very hard rock, the slurry machine cannot work. Even in the slurry machine, if I go to work with a hard rock condition, they install disc cutter inside the machine. So disc cutter will try to crush the rock pieces that will go inside the machine. So the machine can also work on. Okay. Now, how do I select a particular machine? How do I know that whether I need a EPB machine, whether I need a slurry machine, or whether I need a hard rock TBM machine? So first of all, the main thing is the geotechnical behavior of the ground. Before any TBM selection of the project, the client or the TBM supplier, they mostly rely on the geological L section. Geological L section means if I take a particular metro project, if it is a 3 kilometer stretch or 3.5 kilometer stretch, so along the stretch, first of all, we try to collect all the geotechnical information of the ground, and then we plot in a long scale, and we try to find out how the ground is varying. So if it is a very uniform stretch of the ground, suppose if you refer the Delhi Lucknow metro, it's a very uniform ground. Everywhere you get a almost steep to medium steep filled clay, or sometimes it can be bands of sand, but mostly it is a very dry ground. So it is a very favorable choice of EPB machine because we can use a art pressure balance machine. If I go to Chennai or if I go to Bangalore, we mostly prefer say slurry machine because here the groundwater table is very high and we are expecting a very combination of sand and mixture of some portion of rock or boulders. So mostly we rely on the slurry machine with hybrid mode. So groundwater behavior or groundwater presence or how the groundwater can flow inside the machine and also the geotechnical characteristics of the ground mostly predominates of the type of the machine we select. Another thing is the boundary conditions of the project. Boundary conditions of the project means that if there are alignment sometimes passes to a very highly dense populated area where there are lots of buildings, so I might expect some sort of disturbance or some sort of vibration from the machine, or there might be some settlement at the foundations of the buildings. So here we try to rely mostly on the EPB machine because the EPB machine we can control the phase pressure and we can keep a very low phase pressure where we are going at a very low cover region. So and another thing is the experience of the contractor. Experience of the contractor in particular region, if he has worked, he knows how to control the volume loss. Volume loss is a very important concept when you are working in a TBM particularly in a urban region. Volume loss means that there is a gap between the TBM shield and the TBM segments that we're installing, and that gap creates a settlement, or you can tell some sort of uh, movement of the ground. And if the volume loss is very high, that creates a very huge surface settlement. And the surface settlement is very high, then it creates a disturbance to the structures that is lying above the ground. So controlling the volume loss or keeping the volume loss to a minimum and also installing the segments after the excavation and doing the grouting parallelly. So to control the groundwater or also filling the gap between the segments and the ground also. So this is the experience of the contractor. So all these characteristics we combine and then the contractor or the consultant or the client, they jointly make a decision on the particular TBM. So you can see there is a table 1 where you have given that if I go for a rock condition, so if it is a very hard rock, I can go with a gripper TBM. If I need a thrust jacks, that is, I need to take the thrust for the TBM segments in a rock type of ground condition, then I will go to a single shield TBM. If I need with a gripper and the thrust jack both combination, then I can go with a double shield TBM. If I go for a soft ground condition, then either I can go with a slurry shield, I can go with a mixed shield, or I can go with a artificial balance machine. So this is the most of the TBMs we are using, but there are also advanced TBMs, whatever I told. So I will also explain you that. Okay, anyone have any question? Whoever not worked in TBM or whoever any doubt?
There was the
Mhm.
yeah. Yeah, actually, we are new. Just we are going to work indirectly with TVM designer. So just it is for me it is very new. You just
Okay.
explained regarding the thrust jacks. Can you please
Yes.
elaborate it more?
Thrust jacks means actually the TBM. There are two types of operation. One is called the initial drive, and another is called the main drive.
Mhm.
One minute. In the tunnel. Okay. What happens? The TBM, first of all, you are procuring the machine. So the machine is coming, then you need to install the machine. So you need a working chamber for the TBM because it has to be assembled because you cannot lower the whole machine into the ground because it has a weight of 200 tons. Sometimes it has a weight of 250 tons and it has different parts because TBM has a cutter head, then it has a shield, then there are lots of jacks, then it has a backup unit. So what happens? First of all, we make a shaft. Every metro project you can see there is a TBM launching shaft and TBM retrieval shaft. But in several other projects also, what we are doing, we are not preparing a shaft. We are directly launching the TBM from the ramp. That is the cut and cover ramp part. We are installing the TBM. Now, first of all, when you are installing the TBM and when the TBM has to start, then you have to push the TBM because TBM does not get the thrust from the segment because you have not installed the segments or whatever the thrust TBM has to provide to the ground to move. There is sufficient segments needs to be installed first of all. Otherwise, TBM cannot get the desired thrust. So what we are doing, we are preparing a reaction frame. Reaction frame means I can show you the sketch. You can get on it. Yeah. So this is the reaction frame. You can see the reaction frame is basically a steel frame where we are putting jacks, and the jack is pushing the TBM. So, but the jack directly does not directly push the TBM. What we are doing, we are putting some uh, segment rings or precursor rings that is called a sacrificial ring between the TBM and the jack. That is, and then then through the segment we are pushing the TBM. Now TBM is kept on a cradle. Cradle means that is a typical type of frame. That is a steel frame. It can be a concrete frame when which the TBM is pushed. It has been placed, and then through the reaction frame and the segments that is we are putting between the TBM, then the TBM is being pushed. Now the TBM, when it is being pushed, the TBM will automatically start moving. It will start excavating, and then it will build the rings also. And the rings are built at the tail end of the TBM. So what is the tail end of the TBM? I show you first of all. So this is the TBM machine. So you can see this is the cutter head machine. This is the excavation chamber. Here you can see this all these segments are being installed. So this is called the tail end of the TBM. So TBM means it is a 20-meter or 18-meter length of the part. Because when the TBM is working, it is approximately 200 meters, but that is the backup unit because there are generators, there are DGs, there is cooling unit, there is a ventilation unit, there is a medical unit, there are lots of units. So when the TBM is complete, you can see this part. So this is the total TBM machine. It's just like a whole Rajdhani Express, or you can take a Vande Bharat Express. When the TBM is completely installed and when it is full part is being mobilized and it is moving, it is just a full loco train. But if you are particularly speaking of the TBM, there is only the 20-meter part. It is this only this part is the TBM. So from here to here. So TBM has a cutter head that is called the front shield, and TBM has a tail end, and this is the tail end part of the TBM, and the segments are being fed from the tail end part. So there is and when it is being fed, then there is a robotic arm inside the TBM which is putting the segment as per there is a chronology of putting the TBM. Now, initial drive means that TBM is moving and it is installing the segments. Now, there will be minimum number of segments when the initial drive will be finished and the TBM is capable to take the thrust of the segments. So so what happens, the designer, they make a calculation that how much segments I have to install so that my desired thrust has been, TBM can put now on the segments. Now there are two type of thrust. One is called the nominal thrust, one is called the maximum thrust. Nominal thrust means the working thrust. That is normally the TBM is putting on the segments to go move ahead, depending on the type of the ground. If it is a very soft ground, then the TBM will put a very nominal or very minimum type of thrust. sometimes the TBM gets stuck at the tail end, or sometimes the ground is very hard that the TBM cannot move ahead with the nominal thrust, then there is a maximum thrust, or it can call it as an exceptional thrust. Now I give one example. If I take the Lucknow Metro example, so in the Lucknow Metro, the thrust was approximately, the nominal thrust was between 22,000, 23,000. But the exceptional thrust was very high. It was around 27,000, 30,000. But in 3 kilometer or 3.5 kilometer space, the ground was so smooth, just like a button. We never experienced any high thrust region. So almost in a nominal thrust we were. Now, when the segment that the designer has been fixed, that what will be the appropriate or minimum number of segments TBM has to build, so it can move from the initial drive to the main drive. So if you take, it can be 80 segments, it can be 100 segments. So if I take 100 segments has been installed, so what we do, we release the reaction flip, and the TBM starts working on the main drive, and then the TBM is moving, and then it starts building the ring, and then it will taking the thrust from the rings. So this is basically the movement of the tip.
Devanshu sir, I have one more query. Like
Yes, yes, yes.
when you are like when we're talking about initial launch or
Mhm.
main drive, initial drive, so there is the modes are also there, open mode and the closed mode.
No,
That
no, open mode, closed mode, basically it depends on rock. It's not in soil. If you are in every metro, whatever Delhi metro, always you are working in a closed mode. Open mode we work when you are working in Mumbai or Pune. Suppose Pune, we worked always in open mode. Maximum it is open mode. Sometimes it was semi-open mode. Open mode means that you are not applying any phase pressure, zero phase pressure. So that is the open mode. And closed mode means that you have to apply some sort of phase pressure.
but like when you're launching the TBM, definitely
Mhm.
you don't have anything, so there will be no phase pressure, nothing will be there inside.
No, no, no phase pressure. There will be no phase pressure. So
Yeah.
until it sufficiently does not goes to the. That is why I told that until 100 or 80 segments you have not installed. So if you take 80 segments, if you take 1.4 meter length, so it will be 112 meter, 115 meter. So that amount of it has gone, then it can get the desired phase pressure, or it can get the desired phase pressure as well as the you can work in a full close mode.
Yeah, so what my understanding, like full close mode, when your full EPB thing is working, when you have a sufficient muck in the chamber, basically in the excavation chamber, that is
Yes.
balancing out the pressure. And before that, maybe little bit muck part or maybe some compressed air part, it is working it out basically,
Yeah,
uh,
that is
maintaining
another
the
thing. That is
pressure.
the
Yeah.
when you are working in the TBR intervention part, so then you apply a minimum air pressure, because it can be, because the TBM is not getting the phase pressure from the ground, so it is applying a minimum air pressure, or it depends on how much mark is there.
Okay.
Okay, what is your question, Prapurna?
Which TBM is used in both rock and soft ground condition? I have visited a
Yeah.
TBM as part of DC07 project, as far as I remember. So I think it is based on these thrust jacks only. So they told that time rock is not available, something like that. I didn't remember exactly, but they have switched the mode because rock is there, but not soft ground condition, something like that.
Yes, yes, you are right. Because if it is a rock and a soft ground condition, if it is in a urban region, the rock means it's not a very hard rock. That what we experience in the mountains. So
Mm.
if I work in a hydro project, suppose in Kishan Ganga project, if you work in this uh, Parvati stage 2 project, that TBMs are quite different, because that rock is quite high, very competent strength and very jointed rock. Whatever the rocks we are getting in the urban region, suppose in some sort of Delhi, or if you take in Mumbai, Pune, these rocks are mostly competent but not very highly jointed rock, and they are not very high strength rock. So we are using EPB machine, but we are working in two modes. If I getting a very pure rock, very hard rock, we work in open mode. If I get in a sometimes some sort of rock and steep ground, we are working in a semi-open mode. If you are getting a very soft ground, then we are working in a full closed mode. So same machine can switch in 3 modes, either in open mode or semi-open mode or in a closed.
Thank you, sir.
Okay. Anyone have any other question? Okay. Now, how I select between a slurry TBM machine and a EPB machine? So that depends on the permeability of the ground, because permeability, according to the permeability, what will be the structure of the ground and how the groundwater will flow also, and what will be the particle size distribution also. That is a very important. So if you can see that EPB is mostly applicable between a silt clay and silt and some sort of fine sand region. So here the permeability is very low. In a very low permeable ground, mostly clay or mostly mix of silt clay, we are mostly using the EPB machine. So here we are not experiencing a very groundwater ingress to the ground or into the machine. If it is a slurry TBM, we are mostly using in a very high permeable. So permeability is very high. So it's mostly medium grain sand, fine grain sand. So here the water ingress will be very high. So the difference between a slurry machine and EPB machine, the slurry machine, we are using a bentonite slurry. There is a slurry chamber, there is a slurry tank, even there is a slurry circulation plant also. So here we are applying the slurry directly to the ground ahead of the TBM, and that slurry forms a mud cake, and that is trying to put the ground stabilize. So otherwise the ground will collapse. If the ground collapses, then it will be a problem for the TBM also. And also it is controlling the groundwater ingress that is expecting inside the TBM. If it is a EPB machine, here we are not expecting a very high groundwater ingress. It will be seepage, some sort of seepage of the ground. And due to the, if it is a silt or clay, it has some cohesion parts. The difference between the slurry machine and the EPB machine is that the slurry machine, whatever the ground you are working, there is a very low cohesion. So it cannot stand. So it does not have a self-standing property. So if it is a silt clay or if it is a silt, so it has a very high cohesion value. So due to the cohesion value, the ground itself can stand even after the excavation of the TBM. And we are applying a minimum fresh pressure and we are building the ring, still the ground can stand, or it might be the ground will not fall immediately. So this is the slurry shield machine. So there are different parts of the slurry shield machine. So first of all, the number one is the cutter head. Number two is the bentonite slurry. That is the most important. This is keeping the ground stable when the slurry machine is working or when it is excavating, even when it is building the ring also. There is a air bubble. The air bubble part is mostly very important when there is a TBM intervention or the TBM we are going under a maintenance, or sometimes there is a replacement of the cutter head and there is no sufficient muck inside the TBM or not sufficient phase pressure we need. So we are applying a minimum air pressure also. But air pressure mostly we apply whenever we are working in the intervention. Four is the thrust term. Thrust term that I told that this is the part that is applying the thrust to the segments that has been installed. And from this thrust, the TBM is moving ahead. Number five is the segments, that is the precast segment that is being installed from the tail end of the TBM. Six is the tail sealant, or it is the brush of the TBM that is not allowing any ground or any type of water to be go inside the TBM from the tail end part, because you can see that the tail end part, there is a difference of gap between the TBM shield and the segment that is being installed. So that is creating the volume loss. Mostly this is creating the volume loss. Now here we are putting the tail brush, so it is preventing the water or the fines to go inside the TBM. And then there is the seventh part is the bentonite slurry that is fitting for the part number 2. 8 is the bentonite slurry return, or there is a recirculation part of this TBM also. Outside there is a recirculation tank where the slurry is continuously circulated. And 9 is the annulus grout. This grout is very important because when the TBM is being installed, so the gap between the TBM and the soil we are filling by the grout. Annulus grout, sometimes it can be pea gravel, sometimes it can be grout. And it is basically a backfill grout. So it is a very low pressure grout. It's not a very high pressure grout. But after primary grouting, we are seeing that there is a water ingress. So then that time we are going for a secondary grouting. Okay. And in the figure number 2, you can see there are different modes that I already told, because the EPB machine can work in a different mode depending on the type of the ground. So it can, or the slurry machine also can work in a different type of the, depending on the type of the ground. So it not always not the TBM when it is moving, it will work in a very constant mode. So the mode of operation can be different depending on the permeability or the particle size of the ground or the groundwater ingress of the. Okay. Anyone have any question? This is the earth pressure balance machine. The earth pressure balance machine is almost same, but here you can see there is a screw conveyor. So the screw conveyor, basically we are removing the muck. So part number 2 is the working chamber where we are keeping the whatever the earth is being excavated, and 4 is the screw conveyor. This screw conveyor, the earth is removed and or the muck is being removed, and there is a through this screw conveyor it is being disposed outside. Now the part number 2 and part number 4 is very important for the EPB machine working. Now sometimes it happens that I have to release the marks because I don't need a very high phase pressure. Sometimes if I need a very high phase pressure, then I have to keep my working chamber fill, or it can be half fill, or depending on the specific gravity of the mark, it also depends on how much mark I need to keep, or whether I need to mix any type of additives or any type of polymers or any type of chemicals to keep the mark as a bulky. And also whatever the mark is being removed, that is also measured outside. So from there also we are getting an idea. This way indirectly we can get an idea of the volume loss of the ground also. And rest other parts are almost similar. So when you are working in a open mode, or we are working in a closed mode, or working in a hybrid mode, basically the screw conveyor part, it is changed. So you can see here the open mode and the closed mode and the semi-open mode. Basically we are just changing the operation of the screw conveyor. So open mode means that you are not applying any phase pressure. So basically you can remove all of your mark. So you can see in the open mode, there is no mark inside the excavation chamber because I don't need to apply any phase pressure. If it is a semi-open mode or compressed air mode, so half of the mark I will fill in the excavation chamber and half I can apply as a air pressure. If it is a closed mode, so the full excavation chamber should be always be present because I need to apply a very high thrust. Okay, anyone have any question or any suggestion, any idea?
Sir, I have one question.
Yes.
Contractor generally prefer the EPB machine, and in lots of stretch in high amount of sand and silt also, they are using modifier and use the EPB.
Yes.
So that is a safe process, right?
As I told you earlier, whatever the mark is coming, no, there is a scale which you can measure the specific gravity of the weight of the mark, and you can convert it to the volume also. So that is very important because if the specific gravity of the mark, you find that it is a very lower consistency, so then what happens, the ground that you are ahead of the face, it might be very stiffer. So if there is a very high pressure difference, then the ground will start moving inside your machine. So basically, to prevent that, they are using some sort of chemical, some sort of foam, or some sort of polymers or additives to keep the mark more wet or more bulky. It is called as a soil conditioning. Basically, it's a conditioning of the mark or conditioning of the soil that I am removing. Basically, it's the operational part. Neither it is not related to any design. Is it clear?
Yes, sir.
Because as I told you earlier, the EPB machine, how you can work the machine, or whether you need to be worked in a open mode or whether you need to open semi-open mode or closed mode, it's not decided by the designer. is basically decided by the operation or by the TBM operator or the contractor, whoever is working. Because the designer assumes that the machine will work mostly in a closed mode. But sometimes suppose in Pune Metro, depending on the type of the rock, we decided that if it is a very hard rock, we will go in a fully open mode. If it is between a mix between a rock and a soft ground, we'll go in a semi-open mode. If it is a very poor ground, but that is very rare in Pune or Mumbai, because you don't get a very soft ground. In some stretch you can, but Pune it's very competent rock. So it was 80-90% we worked in open mode. Some part of, suppose whenever I am passing under the river, or I am passing some water bodies, or I am passing under the nala, so there I can go in a closed mode, because I can expect a seepage that might come through my excavation chip. Okay.
Okay.
So
So
if you
another
are
one more question, sir.
yes,
Sir,
yes.
when you are using hydro shield in slurry TBM, when we are encountering water, at that situation we are use
Yes, yes.
hydro shield.
If it is a very high water ingress, then you have to use a hydroshield, because in suppose if you are working in Calcutta you cannot expect any. It's always closed mode. And in Bowbazar also, in Bowbazar where ITD was working, at that time the water pressure was so high that it entered the machine, because through the tail end, because the pressure was so high that the point that is sorry one the sixth part, that is the what is the sixth part is that
The
the tail
brush.
the tail brush end got washed out because the
Right.
pressure was so high. And it was EPB machine, but it basically hit a water body. It was a hidden lake actually. It's a very old lake that was hidden inside, and it was directly under the all the very huge residential area. And when the machine hit that part, initially when the water was coming, or when the ground was moving inside the TBM, they closed the working chamber, or they closed the bulkheads. But what happened, due to the water pressure, the peaks, that is the tail end brush, that got washed away, and the water pressure got uncontrolled way, it was entering the TBM. And that is why the TBM got stuck for so many months, and so many buildings got overnight 250 300 buildings got settled, and the people has to evacuate the building immediately. So that is why, if it is a very high water ingress, if it is a very high permeable ground, so here you have to use a hydroshield.
So hydro shield can also work with EPB.
Any machine, AC EPB, it can work. It can change the mode. Nowadays there is no EPB perfect EPB. It is a hybrid mode. EPB only we are using EPB in suppose in Delhi we are using, in Calcutta we are using EPB, but suppose in Bangalore or in Chennai also, nowadays they always prefer to work in a hybrid mode. So I can switch the mode. Anyone have any other question? Now this is the what I told you. This is the multi-mode EPB. Multi-mode EPB means that I can both work in a open mode as well as closed mode. So you can see in the first figure, the upper part they have made is in a closed mode, and the lower part they made in a open mode. Sometimes it can be both EPB as well as slurry also. The same machine can work as a EPB, same machine can work as a slurry. They can change the screw conveyor part, and then it can be two modes also. So nowadays, all the machines that has been prepared by Herenket or Robbins, they're coming as a dual mode EPM. Suppose nowadays you have a hybrid vehicle, you can drive the vehicle both in petrol or diesel, or you can drive the vehicle in electric mode also. Sometimes it is CNG mode, or diesel mode, or petrol mode also. So same the TBM also, they are coming in a multi-mode, because nowadays it has been seen there are lots of ground scenario where the ground after 250 meter or 300 meter, the ground suddenly changes. I suddenly get a water ingress, or suddenly get a very soft ground where even whatever the phase pressure I'm applying, I'm not able to control the phase pressure. So that time I cannot change the mode of the TBM. It's not possible, because I cannot go in an intervention and keep the machine stand still for a long part and then I change my cutter head, then I change my all my other accessories. It's not possible because I have to keep the machine open, running. So that is the multi-mode TBM or the hybrid TBM, which automatically switches depending on the type of the ground. Because there is a TBM, they have lots of sensors, so they can experience what amount of work pressure coming, what is the type of the ground they are doing, proving ahead of the drilling, so they can know what is type of the ground coming, what is the groundwater scenario. So nowadays the TBM has so many highly sophisticated, so many sensors they have. You automatically can identify the type of the ground. They automatically identify what type of work pressure, whether there is a drop in pressure, whether there is a high pressure. So automatically the mode can change.
Sir, in Kolkata,
Yes,
there is an underwater tunnel, na? So in that also we might have used EPB only or
yes,
any.
only EPB. No, no, it is EPB. It is a 100% EPB machine. But the Calcutta one, that tunnel is not underwater. It's a very wrong concept that it is underwater. It's mostly, it is below the river bed.
Huh,
So it is approximately 50 to
520 meter.
15 to 20 meter below the river bed. But people expected there will be lots of water ingress that will come inside the machine, but it was not that case. But the main thing is that all the segments were very heavily reinforced because the thrust on the of the water and thrust of the ground, it was very high. Now this is the TBM machine. So you can see there are four modes. One is the EPB closed mode. Second mode is EPB closed mode with additional bentonite support. The three mode is mixed shield mode with bentonite slurry. Another is that we are completely going in a hybrid mode. So single machine, you can see it can go from EPB to slurry without any mechanical changes. But the point is these machines are very costly. These machines are very sophisticated. So unless client does not have the budget, or unless you cannot, as a designer, you cannot satisfy the client with the ground type that you are expecting, or you do not have a very accurate ground information, these machines cannot be used. So that is why in India we do not very frequently mobilize these hybrid machines. We mostly uh, mobilize either EPB or slurry machine. But in certain in Bangalore also some contractors they prefer to go the EPB hybrid or crossover machine also. So one machine they have four modes. So it can go from EPB to slurry, even it can go work in a open mode, closed mode, whatever mode you need, a single machine can work. But these machines are only prepared by only suppose by Herenkate or Robbins. No other EPB machine supplier they are giving this machine. Okay. Now we come to the rock TBM. Now anyone have any question on soil TBM? Okay. Now the rock TBM, the operation is quite different. It's not just as a soil TBM, because in the soil TBM we have seen that it is applying a phase pressure, it is circulating some slurry, some air pressure, sometimes bentonite slurry, and also it is taking the thrust from the installed segments. The rock TBM, it works basically on the thrust that is taking from the rock surface. So whatever the ground it is excavating, it is taking the thrust from the excavated rock. That is how it is taking the thrust. It is called gripper. So you can see here. So number one, it is the gripper pad. Basically, the gripper pad means it is applying the thrust to the rock surface to move ahead. So when the gripper is in position, or a gripper is in lock to the rock surface, basically the TBM is moving. When it is being released, the TBM is stopping, and then it is installing the segments. So here you can see that mostly it is taking the thrust from the rock surface excavated, and the rock that is ahead of the TBM, it is so competent that we don't need to apply any phase pressure. So it is always working in the open mode TBM. So open mode means that we are not applying any phase pressure. See, in the rock TBM, you cannot see any type of bentonite circulation, any type of excavation chamber. It is completely different mode of operation because this is very competent ground. This type of machine we are mostly using in mountain tunneling. So in India, in hydro projects, we have used this TBM. We have used this TBM in Kishan Ganga hydroelectric project in Jammu Kashmir. It was a double shell TBM. In Parbati stage 2, we have also used this machine. But the problem of these machines is that if the ground is suddenly there is a shear zone, or suddenly there is a cavity, or suddenly there is a fault, this machine gets stuck. And that has happened in Dulhasti project in NHPC. The TBM has been buried inside the Himalayas. Even in Joshimath, there is a hydroelectric project. The TBM got buried and got stuck. And after 3-4 years, they could not extract or retrieve the TBM. So what they made an alternative path to avoid the TBM, and then rest of the tunneling they have completed by the conventional tunneling. So the rock TBM, the problem is that if your rock is very uniform, so in Kishangonga project, it was a very uniform rock. We did not encounter any faults, any fractures, any water body, any shearing, any squeezing zone. So any type of difficult features of the Himalaya, if it is experienced by the TBM gets stuck, and it is very difficult to retrieve the TBM because ahead of the TBM it is completely closed and the TBM cannot come out or come back. It has no reverse mechanism. So what happens that in that scenario, either TBM gets stuck for number of years, or you have to make an alternative channel to bypass the TBM and then you have to work. So if you are not sure, or if you have doubts about your ground condition, if you are gonna have any sufficient geotechnical information, if you don't have investigation data, it is not advisable to go with the TBM in a Himalayan rock condition. That is why you can see, if you see the Himalayan rock condition, very few case studies you will found in the Himalayas. Most of the Himalayan tunnels has been excavated by conventional tunneling or by NATM tunneling. In the European conditions, in the you say in other American conditions or other abroad conditions, the rock are not so difficult or not so challenging compared to Himalaya. So here the hard rock TBM works even in the Norwegian ground condition, because the ground is so highly competent, it is so hard, and it is uniform ground conditions, so the TBM can work there. So if I take the rock TBM, so there are 3 types of TBM. One is called the shield, one is single shield, double shield, open type. Open type means there is no phase pressure. It has a basically very high advance rate, and it is mostly moving through the gripper pressure. Double shield machine and the single shield machine, as I told you earlier, if it is a poorer ground condition, the single shield machine you are using, the single shield is allowing for the TBM to advance, and simultaneously it is building the segments. So when the TBM is moving, the segment is not being built. So once the segment is built, then the TBM is not moving. In the double shield, what happens? The TBM can advance and it can build the segment simultaneously. So the double shield TBM is a very fast operation, but it depends on, if you have a very competent rock condition, you can use a double shield machine. So your advance rate will be very high, and simultaneously you can install the segments parallel. Now, how do you select a rock TBM? The rock TBM, there are lots of parameters on the selection, but the main parameter is what is your unconfined compressive strength. The UCS value of the rock, or if you can take, it is a RQD value of the rock quality designation. So basically the strength of the rock, you can dictate the type of the TBM you are going to use. So this is the one standard chart you are using. According to the RQD value, so you can directly correlate the RQD value with the UCS value or the uncompressed compressive strength. And from there, you can know that what will be my performance rate. So this is one guideline, but there are lots of parameters when you are selecting a rock TBM, because what happens if it is a very hard rock, I will have a lots of tear and wear of my cutter head, because the cutter head teeth, it will have a lots of tear and wear, because it is very difficult to cut the rock if it is a very high strength rock. Suppose the rock has a UCS value of 100 MPa or 120 MPa, it will be lots of wear and tear, and I will have a frequent cutter head intervention, that I have to change my cutter head very frequently. In Bangalore Metro, AFCONs reported that after every 25-30 rings, they have to change the cutter head, because sometimes the rock was so hard that even the cutter head 25 rings means if you take 1.5 meter or 1.4 meters, approximately 35-40 meter advance, they have to change the cutter head. So that is another thing that we need to, when you're selecting the type of the TBM, you need to keep on the mind that what will be your abrasivity rate. So this is called the disc cutter life versus culture index. Culture index is very important. Whoever worked in the rock TBM, he has to know the culture index value of the ground. So culture index is basically correlated with the unconfined compressive strength of the rock. So if you have a very uh, high culture index value, so your tool rate or your cutter, your tearing rate will be very high. So basically, there are three things. One is the uncompressive compressive strength of the ground. One is the RQT value of the rock. Another is the culture index of the. So accordingly, you have to see the what will be my wearing tool rate or what will be my penetration rate, what will be my cutter head life, what will be my cutting rate. So all these parameters comes into the selection of the type of the TBM or selection of the type of the teeth of the rock or type of the cutter head of the rock. Now, this I have already explained. This is the open TBM. So this is the single shield TBM and this is the double shield TBM. Now I come to the crossover TBM. The crossover TBM, that is the most advanced TBM now we are using. It is a TBM that is used when there is a mix of rock and ground. So there are two types of crossover TBM. One is called the XRE machine. X means the crossover, R means the rock, E means the EPB. So this machine can work both as a EPB machine, as a closed mode machine, even it can work in a rock as an open head machine. So one machine, it can work in a very soft ground and it can work in a very simultaneously hard rock condition. So suppose I have encounter a particular stretch where I have a mixed type of ground. So if I see that above the spring line, I have a very mixed type of ground, very soft type of clay or some sort of mix of sand and clay. And the bottom of the spring line, I have a very hard rock condition. I can use this EXRE machine. So it will be a combination of the rock and EPB machine. So it can work in a closed mode as well as it can work as an open mode also. Another machine is called the XSE machine. XSE machine means X is the crossover, S is the slurry, E is the EPB. So here you have a combination of both slurry as well as EPB machine. So you can work in both high permeability ground as well as a low permeability ground. So if you have a stretch of a very high permeability as well as a high water ingress ground, you can work as a slurry TBM. If you have a very low permeability ground, if you have a very low seepage condition, if you have a ground where the ground stiffness is very high, I can work as a EPB machine also. So you can see nowadays we have so many combinations. The single machine can work as a EPB machine as well as an open mode machine. Single machine can work as a slurry machine as well as a EPB machine. So there is not a single type of TBM, particular type of TBM. It's a mix of TBM, and in any ground condition, it can deep through the ground without any type of intervention. Okay, any question you have? Okay, now we come to the what are the risks in the TBM tunneling. There are lots of risks in the TBM tunneling compared to the open ground, open conventional excavation. Because what happens in the conventional excavation, we can see the ground, we can see the tunnel face, even what is happening in the ground, we can understand, and if required, we can put an additional supports also, or we can change our excavation mode also. But the TBM is a closed mode operation, so you cannot see the TBM face unless it is an intervention mode. If you when the TBM is stopped, so then you can go from inside from the working chamber to inspect the cutter head. And also, if the TBM is encountering a different ground condition, so you cannot change the type of the supports. So First of all, the main problem is the mixed ground condition. If it is a very hard rock strata, if it is a mix of soft and hard rock strata, so you can experience a high cutter rate. Cutter rate means the cutter head teeth, it will tear and wear will be very frequently. So you will have a very low cutting efficiency. Even it is a very mixed type of soil, you will have a very high ground loss. So if you can have a very high volume. So one problem of the TBM is that if it is designed for a particular type of the ground, in a mixed ground condition, it will have lots of problem. One of the problem is that in a hard rock, it will have a very high cutter rate. In a soft ground, it will have a very huge volume loss. If there is a high groundwater condition, there can be more groundwater ingress inside the TBM. So you need a high phase pressure. The main problem is in the rock. If it is a very fault zone, shear zone, or weak type of ground conditions, there are frequent chances of the TBM gets stuck, and also it will be very difficult to retrieve the TBM also, particularly in a squeezing ground or in a swelling ground. The shield can get blocked also. There can be cracks in the lining segments due to the high pressure of the ground. And similarly, if it is a high in situ stress, high water pressure, if it is a cavity, so this type of conditions, particularly in the Himalayan regions, TBM cannot tackle these problems, because till date, all the TBMs around the world, whatever have been manufactured, they are not 100% or at least 70-80% suitable for the Himalayan rock conditions. Because in the Himalayan rock conditions, we encountered a very high mixed groundwater conditions. There are frequent fault shear zones. There sometimes we encounter squeezing ground, high in situ stress, high water pressure. So all this combination mixture cannot TBM tackle. So risk in the TBM tunneling, mostly it is if you take as a mountain tunneling, our till the TBMs are not fully equipped to handle the Himalayan ground conditions. If you take up the urban ground conditions or the whatever the TBMs that are working in the metros, the main problem is the control of the volume loss or control of the ground loss. So if the ground loss cannot be controlled, but sometimes if the whatever the grouting we are doing to the segments, if the grouting is not done properly, so due to the ground loss, there is a settlement of the ground, and we see sometimes in several projects that buildings got damaged. Either building are getting cracks or buildings are getting tilted, or sometimes there's a cavity formation ahead of the ground, or sometimes there is a busting of the ground ahead of the TBM. This is the very frequent we are seeing in the TBM tunneling. Another problem we get in the TBM tunneling is the cracking of the segments. This is a very interesting problem, and there is a very common problem in all the projects. In my experience, in two projects in Ahmedabad Metro and Lucknow Metro, we have seen that segments got cracked. And around in Lucknow Metro, around 400 segments we found that got cracked. And the cracking pattern is very different. Sometimes we are getting crack in the bolt pocket, sometimes you are getting crack on the body, sometimes you are getting crack on the leading edge of the segments, sometimes we are getting hair crack, sometimes we are getting line crack, sometimes the crack width is very high, the crack width is high, the water is coming out of the cracks, grout is coming out of the cracks. So this is one of the very common problems. And another problem is the stepping and leaping problem, that the segments sometimes get instead of the offset, the segments get connected in a single line, or it can be a stepping problem, or it can be leaping problem. Okay. Okay. Anyone have any question? Okay. Everyone have understood what I explained now.
Sir.
Okay. Very good. If anyone have any doubt, please raise your hand or please ask me. Okay. Next is what is the TBM operation process? Nowadays, whatever I've told you, all is the TBM basic features of the machine, but there are lots of advanced features. There are lots of that cannot be discussed in a single, and there are lots of publications. I will refer you further. So first of all, how we are launching the TBM? The launching of the TBM, as I told you earlier, it can be launched through a shaft, or it can be launched from a open ground or a curtain cover ground, ramp region or the curtain cover region. Suppose in lots of projects you are seeing that is a TBM launching shaft. Now, first of all, if it is a TBM launching shaft, then you have to prepare the shaft. So that shaft can be a temporary shaft or it can be a permanent shaft. It can be, the shaft can be prepared by a diaphragm wall. It can be prepared by a soldier pile. It can be prepared by a contiguous board pile or second pile wall. In Kolkata Metro, we prepared the launching shaft by diaphragm wall because the ground was so soft. So if I go with a second pile or if I go with a contiguous board pile, the wall itself will deflect so much that all the structure that is lying above the ground might get heavily settled. So we have gone with a diaphragm wall. Even we encountered water seepage also. So to make it as very water-tight structure in Calcutta Metro, we prepared a very deep, very long diaphragm wall shaft. In Mumbai, since you have a very mixed ground condition, initial 3-4 meter or 5 meter, you have a soft ground. After that, you get a competent rock condition. So mostly people go with a second pile wall or a contiguous pile wall of 5 meter, 6 meter initially. After they go for an open. Similarly, in the Pune Metro also, we have gone with a initial 5-6 meter of the wall by contiguous board pile or second pile wall. After that, when you are getting a hard rock condition, we have gone with a open cut by just open cut and stabilizing the rock by short fit and rock bolts. In Ahmedabad Metro, we have gone with a diaphragm wall, and in Lucknow Metro, we have gone with a soldier pile wall. So the first operation is building of the shaft. Once the shaft is built, then we are preparing the that is called the cradle of the TBM, where the TBM will be put. So as I explained to you earlier, so this is the cradle of the TBM. It can be a steel structure, it can be a reinforced structure. So it's a basically temporary structure where the TBM accessories will be placed. So once the cradle is placed, then we are lowering the TBM by there is a crane. There is a very high ton crane where we are lowering the TBM part by part. So once the TBM is lowered inside the shaft, then it is built in different parts. Now, this is one type of structure, how we are launching the TBM. Another is called the launching chamber or the fake tunnel. Basically, you are not preparing any shaft, you are preparing a tunnel or you are preparing a cavern, and you are mobilizing or you are installing full TBM inside this tunnel or the cavern, and then you are gradually pushing the TBM towards your face, towards your tunnel face. So this is one type of operation. Another thing is that you can go with a flying launch. Flying launch is a very interesting concept, but this concept is not used in India. It is used in abroad. It's basically, I show you the flying launch. Yeah, the flying launch is basically instead of the reaction frame, there is some sort of P-stress anchors. Conventionally, we are using the reaction frame to push the TBM towards towards the ground face. But in the flying launch, we are pushing the TBM by P-stress anchor. There is a reaction frame, but instead of jacks, we are pushing the anchors by push. Instead of the jacks, we are pushing the TBM by high stress anchors. This flying launch of the TBM is a very specialized. It's not used in India. Now, the TBM has two type of operation. One is called the initial drive. Another is called the main drive. So initial drive, as I explained you earlier, when the TBM starts moving, so we are pushing the TBM by the reaction frame, and there are sacrificial rings that is pushing the TBM. So the sacrificial ring through the reaction frame and the sacrificial ring, the TBM is being pushed, and it depends on how much ring I need to install so that the TBM can get sufficient thrust from the whatever the segments has been installed. So it can be initial 100 meter, it can be 150 meter. It generally the designer decides that how many segments I have to minimum install. So in Lucknow Metro, we made some calculation, back calculation, and we found that approximately around 100 segments when you're installing. So that is means 140 meter we have excavated and 140 meter we have installed the segments. So 100 segments we have installed. So my initial drive has been finished. So then my main drive is starting, and the main drive means that the TBM is capable to fully excavate and fully install the segments. So here it does not need any backup thrust. So in the initial drive, there is a backup thrust for the movement of the TBM and also for the installation of the segments. In the main drive, there is no backup thrust. So the TBM is taking the thrust from the installed segment. So, and as I told you earlier, apart from the launching shaft, it can be installed from a fake tunnel or a inside a cavern. You just assemble the TBM and then you're gradually pushing the segments. Now there are other part also in the launching shaft. One is called sealing ring. The sealing ring is basically a rubber gasket type of structure. That is basic. What happens? It is a watertight structure. When the TBM is this is the TBM face. This is what you can take is the eye of the. Basically, this is the part that the TBM is breaking and it is moving inside the ground. So we are putting a sealing ring where we are expecting a high water ingress, because when the TBM is moving, when it will break the ground and TBM starts moving, so might be the water from the behind the diaphragm wall or behind the retaining wall, from the ground the water will start percolating and it will try to come inside the my shaft. So we are putting a water sealing ring to control the water ingress. But the sealing ring is not a universal structure that will be used any project. In Calcutta Metro, we use the sealing ring, but in Lucknow Metro, we did not use. Even in Ahmedabad Metro, Pune Metro, we have never used. The TBM directly excavated through the ground. And another is, and sometimes if the ground is not very competent, or if you are experienced, if you have a very soft ground when the TBM is trying to break the ground, so we are doing some ground treatment also. Either we are doing some slurry wall behind my TBM eye, or sometimes we are doing some grouting operation. Sometimes we are doing ground freezing operation. Ground freezing operation we are mostly in UK in crosswell projects. In some of the shafts they have done ground freezing because they experience a very high water condition or the ground was so soft. So they have sealed the ground. They have made the ground impermeable by ground freezing. And so this is the basically the operations we are using for the TBM launching. So here you can see this is the launching shield. This is the cradle. So the cradle, the TBM is being placed and gradually it is pushed through this phase. And here we are pushing the TBM by the sacrificial rig and the reaction flow. Now this is the all the steps of the TBM. Yes, please.
Just I would like to ask
Yeah.
something. Because here my case, I have seen the contractor design. So
Mhm.
actually what they are doing, they are going to launch TBM for cut and cover section.
Yes.
So actually I would like to know what are the design considerations when TBM is launching for the cut and cover.
Cut and cover means you are launching from a ramp.
Yeah, because they have submitted their one design report.
No, and they are not preparing any shaft. No, they are not preparing any shaft.
No. This is what I now you gave three cases,
Oh,
right?
okay.
One is
It's a
open
basic.
cup, one
No,
is
no.
shaft, one is
Yes,
cut and cover.
yes. It's
So
basically
it is
it depends.
my case is yeah.
It's basically neither with the design. It is basically availability of the land. In Calcutta Metro, we had a very limited area, so only the operation was to go with a shaft because we did not have any open ground. If you are working in
Oh.
a very dense populated area where there is a
Mhm.
limitation of the land, because for the TBM operation you need a very huge land. One is for the preparation of your TBM logistics part. So if you study the TBM logistics plan, you can see that a very huge area has been taken for the TBM assembly part, all the TBM, the bentonite circulation tank, and there are lots of things you need. So in a urban area, if you have a very limited area, you have to go with a shaft because in the shaft you can do all your operation. But
Shaft means
in
I don't get it. Is it like vertical or horizontal? How much
no, it's
diameter?
a
It may be
vertical
different.
shaft. It's
Vertical, right? Vertical shaft.
a
Yeah.
vertical shaft. But in Lucknow also we did not had any plenty of land because we are working in a city. In Ahmedabad also we are working in a city, so we prepared a shaft. But in Pune, our TBM was launched from agricultural ground. So agricultural ground means it's an open ground. So we did not prepare any shaft. We directly launch the TBM from the cut and cover structure or RAM. We can from the open ground we launch the TBM direct. We did not prepare any shaft. So whether you want to go with the shaft or whether you want to launch the TBM for the cut and cover, it's a operational logistics part. But what is your availability of the ground? Another thing is that what is your construction program also? Because if you go with a shaft, the construction of the shaft, supporting of the shaft, it takes a long time. So it will impact your TBM operation also.
No, actually, see, cut and cover is part of the alignment. It is same shaft also. It is the part of the alignment, or it is like the separate structure will be created to.
It depends on what is the purpose of the shaft. Sometimes the shaft can be used in a crossover structure. Sometimes you can use the shaft as a ventilation structure. So it depends on cut and cover. If you are
Mhm.
launching the TBM from the open ground, cut and cover ramp will be part of your alignment. Now, if you are building a shaft, what is your use of the shaft? In Calcutta Metro, our shaft was a crossover structure. So we are crossing the trains there. So our shaft is a permanent one. In Lucknow Metro, we did not prepare any shaft. What we did, we launched from the station itself. So the shaft that we prepared, that is a part of the station. So what we did, we prepared half of the shaft and then expanded the shaft later. So it depends on what is the purpose of the structure.
Yeah, see, for us is mainly this cut and cover is the part of the alignment. So they are going to start
Yes,
with TBM
yes, that
launching
is
from cut and cover.
yes,
So
yes,
it move forwards from there to until
yes, yes,
last
yes,
station.
yes, yes, yes.
Uh, yeah, here just I would like to know because the TBM maybe it is too heavy, right? When it is launched, there are a lot of things to be taken care. Maybe some gantry foundation they have to prepare, and they have to,
The gantry is
uh,
mostly
you know,
for the lowering of your TBM and lowering of your segment
TBM
also.
exactly, exactly.
Lowering of your TBM. But if you are preparing a shaft, you need a gantry because the gantry will move over the shaft. But as I told you earlier, in the Pune Metro, we did not prepare any shaft. We directly launched from the open ground. So what happened? The open ground where you have launched the TBM, that is the interface between the elevated and the underground. So at the interface of the elevated and underground, we have launched the TBM directly from there.
Mhm. And also
So
you
it
said
depends on your
something, no? Hmm.
yeah.
Yeah.
So
Tell
it
me.
depends on your alignment, depends on your purpose also, depends on your logistics also, because it's a completely operational part. And also you need to see what is your timeline, what is your baseline schedule. Accordingly, if you are preparing the shaft, so your shaft excavation will take a long time because you have to excavate, then you have to support the shaft, and then you have to put all your once the shaft is ready, then you can start operation. So that is why the Delhi Metro, they are not they are making a very small opening. They are making a not a full length shaft. They are making a small length shaft, and then they are lowering the TBM part by part, and then they are starting the TBM. And also sometimes it depends on the manufacturer. Also, Terratic TBM, it does not need that the full all the accessories has been lowered and all the accessories has been mobilized. Then you start the TBM. It can start that your your cutter head and your shield is lowered, and then your backup unit is above the ground. It can work, it start working. But if it is a Herenket machine or if it is a Robbins machine, it needs the full backup unit to work. So there are lots of things that because in Calcutta also this same question came that in Delhi Metro they are making a 20-meter long shaft and the TBM is being worked. But in Calcutta, why you are making a 100-meter shaft? Because it depends on the TBM types also and the TBM manufacturer also.
Yeah, but as you said, maybe it is depends on the space restrictions, right?
Yes,
Like
yes, yes. Because
maybe.
in Calcutta, we did not have so much ground that we can make a very huge logistic area because everything we have to, all the assembly operations we have to do inside the shaft. So the traffic movement does not get disrupted or I do not obstruct the other part also. So it's a
Okay.
completely logistics, your timeline, because if you have a timeline that you can make the shaft, or sometimes what they are doing that they are making a temporary shaft and then later they're converting to a permanent shaft. So
Yeah, this is what
nothing.
I'm telling you. See, if you know the
uh,
alignment, part of the alignment. So
Yes,
maybe
yes.
client may decide like because no one will don't want to invest the money for nothing, na? Just maybe they see that okay, cut and cover cut and cover or either shaft. It is should be maybe part of the alignment, right? So based on the spacing restrictions, maybe space availability, they will choose which is the best option.
Well, this is not paid. This is not paid because the TBM operation,
Hmm.
whatever you do, it is not paid by the contractor client fully. You have to decide which mode
Mhm.
you are, which is the part you want to go. So that is I told that in Lucknow we had three stations: Sachibalai, Hazratganj, Husainganj. So we launched the TBM from Sachibalai. Sachibalai itself is an underground station. So what we made, the station is itself is 120-meter long or 100-meter long. We have excavated only 30-40 meters of the shaft, and we have excavated the shaft and we have supported the shaft by soldier pile wall. So once the TBM operation has started and TBM has moved inside sufficiently, then we started excavating the shaft and then we made it as a permanent shaft.
Yeah, it is. I believe it is more difficult now when you're launching TBM through shaft. When it compared to open ground, definitely it is very easy compared to cut and
But
cover.
yes,
Because
it
you
is
need
cut
to
and
give
cover
the
is
more.
easy. Cut and
Yeah.
cover is
This is
easy,
what-
but as I told you, it depends on availability. How much land client has handed over to you.
Mhm.
Client also has their own land acquisition plan. No, so whatever the land acquisition plan, client will give you that amount of land, because if you want extra land, then the client has to purchase that land, and it is not that the land he will get, because if it is in a very dense area, it's not possible to get that amount of the land. So in metro cities, it's not easily available that you will get a land. So mostly we rely on the launching of the shaft, launching of the TBM through a shaft. Now
So
the
when
shaft,
apart from
mm,
this, yeah, when it is launching, there is
mm,
any movement like ground monitoring movement shall be taken care.
very less. In the
The
launching, there is no during
no.
the TBM launching, there is a very less movement, but even you can
Mhm.
put some instrumentation in your launching shaft, or you can put some instrumentation on the ground. But main movement comes once the TBM starts moving, and in the initial drive, the mostly the maximum movement you get once the TBM is going in the main drive, and if you control the phase pressure, the movement is very low. Even if you compare the volume loss, we as a designer we take a volume loss of 0.5%, 0.75%, but practically if you monitor the volume loss, it is 0.25%, 0.3% if the operation is very well. But sometimes it happens that at certain stretches you are getting a very soft ground condition, a water ingress condition, or might be the volume pressure you cannot control. Then the volume loss go beyond sometimes 1% more than 1.25. But the TBM launching operation, you get a no ground movement, no nothing. It's a very smooth movement.
Okay. Then other thing just you told that seal.
Yeah, you know. Anyone have any other question?
Hello.
Yeah, please.
Sorry, I think okay.
No,
I asked the
no.
question. It was in okay. Yeah, other question. There was a ceiling ring, na? Just you. Yeah, this
Yeah,
ceiling ring.
ceiling ring, yes, is basically what happens that when the TBM, there is a TBM, there is a break in and break out. Break in means that when the TBM is starting the operation. So it is trying to break the ground and starting the operation. Breakout means when the TBM has completed its operation, or at the intermediate part, it is coming out where you are receiving the TBM. So TBM break-in means that it is the launching part of the TBM. Breakout is where you are receiving the TBM at the intermediate shaft. So in the break-in and breakout operation, what happens if your ground has a very high groundwater condition, or you're expecting a groundwater seepage or ingress, so what you are putting a sealing ring or a rubber type of material. Basically, it's a gasket type of thing where you are making a impermeable or watertight structure between your TBM interface and your wall. So it can be a diaphragm wall, it can be a second pile wall, it can be a contiguous board pile, any type of. So between the wall and between the TBM, whatever the gap or whatever the interface is there during the breaking, if the water is the ingress is there, to control the water or to control the ground to be collapsed, we are putting a sealing ring. So it's basically a gasket type of thing, but it's not necessary at every project. It depends on what is your type of the ground, what is the permeability of the ground, or if you're expecting some sort of water ingress inside during this operation, then we are putting a ceiling ring. It's in Calcutta Metro, we put a ceiling ring, but in Pune or your Ahmedabad, Lucknow, we never put a ceiling ring because we did not expected that amount of water in.
Because even I don't know because I did not go more details. Even I have seen the ceiling ring here because there is no groundwater table in Riyadh. The water table is more deep,
Yeah, ground
like around
area
50
is,
meters below.
but
But
it
still,
depends
they
on
delayed. Yeah.
it is not necessary that you need to put it. It's not necessary. Basically, it's a
Okay.
gasket. Whatever the same gasket you are using in the TBM segments is, basically it's making a watertight structure only.
Okay. Thank you.
So this is the step of the TBM movement. So first of all is the preparation of the site and the TBM assembly of the TBM. Then is the launching of the TBM. Then the TBM, once it is launched, it has two mode of operation. One is the initial drive, and next is the main drive. And initial drive and the main drive, there is the excavation and the mark removal and the support installation. So it is doing all the things in a one go. It is excavating the ground. The ground that is excavated goes in the excavation chamber. Then you are removing by the conveyor belt, and then you are simultaneously installing the support. So at the front shield end, it is excavation is happening. In the rear shield end, the supports are being installed. Now all the segments that has been installed when the TBM is moving, the segments are precast segments. That is already, it has been casted in a segment factory. So before your TBM operation, there is a segment factory where you are casting the segments. There is a segment mold. Inside the segment mold, we are putting the reinforcement, and then we are pouring the concrete, and then it is cured for this steam curing is being there, and then the segments are being transported to the segment yard. Then it is being stacked. I just show you how it is stacked. So this is the stacking process of the segment after the segment is being demolded. So there is one molding operation, another is the demolding operation, then there is the stripping operation. Stripping operation means the segments are removed from the molds. So yes, this is the stacking of the segment where it is being cured and it is the strength is being it is advanced. During this stacking, prior to the lowering of the TBM, sometimes we are putting the gasket, that is the EPDM gasket, along the periphery of the segment, and after the segments are being lowered inside the shaft, and then it is being fixed in the tunnel in the excavation line by the TBM robotic arm. And there are different number of segments for different tunneling operations. Sometimes it can have a 5+1. One is the key and five the other part of the segment. The total six segments makes a complete ring. Sometimes it can be 8+1, sometimes it can 9+1. I will explain that how these numbers has been fixed depending on the time diameter of the tunnel. Now, after the segments has been installed along with the EPDM gasket, and once the complete ring has been built, then we are doing the grouting operation. The grouting operation is basically to fill the gap and also make it as a waterproofing structure. So the gap is between the tail end of the TBM and the segment part. So that is a gap of, sometimes it can be different TBM manufacturers have different type of gaps. It can be 25, sometimes 50 mm, sometimes 35, sometimes 40 mm. It depends on different TBM has different type of dimensions. So this gap is mostly filled by grout, and the grout acts as a backfill material as well as it is a, you can take as a packing material. So there is a complete bonding or complete interface, whatever it is there, it has been filled by the grout between the ground and the TBM segment. That is called the primary grouting. After the primary grouting, if you see that still the water is coming through the grout socket or through the bolt pockets, so then we go for another round of the grouting, that is called the secondary grouting. This grouting are mostly backfill grouting, so you are not doing grouting at a very high pressure. And this is the process of the TBM. So excavation, mark removal, support installation, grouting. So this is a complete cyclic process, and accordingly the TBM advance. Now the advancing of the TBM depends on the different type of the ground. So if it is a very soft ground with a high water ingress, the TBM advance will be very low because you have to apply a very high pressure. Your penetration rate is also very low, and also you have to take care of all the structures that is lying above the ground, because if it is a very soft ground, you have to provide a very high pressure. So also you have to control the phase pressure so that the ground does not get settled, or whatever the structures that is lying above the ground, that is also does not encounters huge settlement. If it is a very smooth type of ground, or if it is a very favorable ground for the TBM, that you don't have a groundwater seepage, or the ground stiffness is very high, uh, then you can excavate the ground by the TBM, and the advance rate can be 10 to 15 rings, sometimes 12 rings per day. So each ring will be 1.2 meter to 1.4 meter wide. So approximately in each shift, can be 15 to 20 meter. So in the both shift, it can be 40 meter to 50 meter. In metro projects, normally, if you compare Delhi, Pune, Bangalore, Mumbai, it generally we get, if you compare the both shift, around 15 to 20, sometimes 10 to 15 rings we generally install per day. Now, once the TBM starts working, so it is not continuously. If it is a 3 meter long stretch, the 3 meter long will work the TBM. There will be intermediate shafts also, or there will be intermediate removal of the TBM for the maintenance part also, or for the intervention part also. So either we retrieve the TBM from the station box, or either we make some intermediate shafts or temporary shaft where we can extract the TBM. So TBM, there is one is the launching of the TBM. So it can be done through shaft. It can be done through some small tunnel or small cavern, or it can be done from open ground, either from cut and cover structure or from ramp. And at the intermediate point, we can retrieve the TBM also from a open ground, or from through a tunnel, or through a temporary shaft. It depends. It's basically logistics operation. It's nothing to do with the design. It's mostly decided by the TBM operation team or the site execution team who are working, that how they will launch the TBM, how they will break through the TBM, how they will extract the TBM at the intermediate point. But all these temporary structures that has been designed for the TBM assembly, TBM launching, TBM retrieval, these things are designed by the contractor, and this design is mostly weighted by the detail designer of the contractor. So this is the part of the designer. Now, once the TBM operation is completely finished, your TBM has been recovered, or all your backup unit has been removed, all your segments is in place, then we go for a regal survey. Regal survey means that you check the alignment of the TBM, and you check that where there are the deviations of the segment. Because what happens that every segment opening, suppose if it is a 5.5 meter finished dia of the TBM, so it has a certain tolerances. So every structural part, they have a tolerance. So if you see here, here you can see there is a tolerance part of the, there is a tolerance for the precast segments. So there is a construction tolerance, there is a tolerance even after building. So we check that whether the rings that we have installed, they are lying within the tolerance limits. So that is the part of the regal survey. So if it is a 3 kilometer tunnel, so either you have installed 200 rings or 250 rings. So you check all the 200 rings that is lying in a line, or as a 3D, if you see, so whether all the rings are within the tolerance part. So if it is not within the tolerance part, so we do some rectifical measures to ensure the durability of the segment. So it can happen that some of the segments, either due to the stepping, leaping process, it can go out of tolerance, or might be some of the rings are lying within the tolerance, but still it can affect the durability part of the long-term performance of the TBM. Then we are doing some rectification. Some of the TBMs might get cracked. As I told you earlier, that after the TBM machine has gone breakthrough, we check every individual segment, and we found that some of the segments either get cracked at different position. It can get a crack at 3 o'clock, it can get a crack at 6 o'clock, 9 o'clock. It can get a crack at the crown, it can get a crack at the center line, at the spring line. So we check the nature of the crack first of all, and what is the type of the crack. It is a dry crack, it is a wet crack, whether there is a water ingress, and main thing is what is the width of the crack. And also we put sometimes a crack meter on the segment, and we monitor the cracks, whether the cracks are opening further, whether the cracks are self-healing cracks. Sometimes the crack gets healed automatically within time. So these are the records after the TBM segments has been built, TBM has been dismantled, or TBM has been retrieved. So this is the final we are doing. And once it is satisfactory by the designer checks that all the segments are within the tolerance limit from the legal survey data. So then he gives a clear signal that the civil work for the tunnel segments is over. Then next comes the track installation part, then the ventilation, lighting, safety, other drainage part or whatever the part is coming. Now, this is called the very interesting part, how the TBM is moving, because your alignment is not always horizontal or not always straight. Sometimes it can be a different inclination. Sometimes it can go in a right-hand pattern. Sometimes it can go in left-hand pattern. Sometimes it goes upwards. Sometimes it goes downwards. So how the TBM understands, or how the TBM encounters this type of curved alignment. It can sometimes, it has to be that it is going through a very tight curve situation. Sometimes it is going, the TBM goes lower and it goes upper. So according to the alignment, how the TBM changes position. That is called articulation of the TBM. The TBM articulation is basically the TBM can move in a left-hand pattern, in a right-hand pattern. It can move upward pattern. It can move a downward pattern. There are articulation jacks. You can see that the TBM shield, there are there are two type of jacks. One is called the pushing jack. Another call is the articulation jack. Pushing jack is basically, that is the jack that is giving the thrust of the segments and it is allowing the TBM to move. But the TBM movement direction is being controlled by the articulation jack. So the articulation jack, it is basically controlling that whether the TBM has to go in the left-hand direction, it has to go to the right-hand direction, or it has to go with the upward or downward direction. Now, previously, all the TBMs that were there, they are designed for a passive, they are designed for a active articulation system. So there are two types of articulation system. One is called the passive articulation system. Another is called the active articulation system. The passive articulation system happens that there is a slight deviation when the articulation system is working. It is not appropriately in line with the TBM shield. So it is not following the TBM shield is not following the pattern what the articulation jack is dictating it. So nowadays they have gone with a active articulation system. Even in a curve, the TBM jack the TBM shield, it is almost following the curve pattern, and also the segments that has been installed also, that is also following the shield or the curve pattern. So you can see here, even in the curve, the shield and whatever the segments you are installing, that is always following the curve. But it cannot happen that always it will follow. Sometimes what happens, that the shield is moving, but the segments are going out of the curve. So in several scenarios, we can see that in a very tight curve situation, if the curve radius is very high, or if it is a very steep curve situation within a very short length, sometimes the shield has moved, but the TBM segment got stuck, or sometimes the tail end gets stuck, and the TBM is not able to move because of this tight curve situation. This situation happened in one of the stretch in Ahmedabad Metro where there was a very tight curve, and the TBM shield end got stuck because the front shield was able to encounter the curve, but the tail end of the shield was not able to encounter the curve, and it got stuck with the segments. So at that situation, what they did, they applied a very high thrust to get that shield extracted from the curve, but that created extra thrust onto the segments because the segments are already installed, and if you apply a very high thrust, that thrust gets transferred to the segments, and then we had a series of cracks on the segments. So this is one of the problem when the TBM is encountering a very steep curve. So in the very steep curve, the articulation system has to be very efficient, or the TBM operator has to know that how he has to encounter this curve. But this is Every time we are telling this, but this is not possible because in several situations we see that this creating the stepping process. This is the stepping means that the two segments has created an offset between the two segments. It is not in line. You can see certain offsets between these two segments. That is called the stepping of the segment. So stepping of the segment mostly occurs when you are encountering a very steep curve or whenever your alignment, your shield is not following the exactly the alignment, or your sometimes the shield of the segments, they are going out of the alignment. To encounter this, to cater this situation, there is another modification done inside the TBM that is called the copy cutter. Copy cutter means ahead of your, instead of your cutter head, there is a small additional cutter system that has been kept. So if it is a very steep cut, so instead whatever the mass that a cutter head has excavated, there is a copy cutter that excavates the extra. So that is a over excavation. So the shield can get out of this curve situation or the steep curve. So the shield and the segment can come out of this situation. So basically the copy cutter is to facilitate the movement of the TBM when it is a very steep curve or a very tight curve situation. Ahead, apart from the TBM movement, there is another part that is called the TBM cutterhead intervention. TBM cutterhead intervention is basically the maintenance, inspection, replacement of the cutterhead or the maintenance of the machine also. Now there is a very important term that is called hyperbaric intervention. It is a very important term or very frequent term. People who are working in the TBM, they are using this term hyperbaric intervention. Hyperbaric intervention is mostly done when the TBM is working in a highly groundwater table, or the TBM is going inside a water body, or the TBM is working in a ground that is very highly saturated, or the groundwater table is lying above the crown of the TBM. So there we are using hyperbaric situation. Hyperbaric situation means it is a compressed air situation, and you have to keep a phase pressure ahead of your TBM because to keep the ground stable. So it can be mix of a compressed air, ground pressure to keep the phase pressure ahead, so that the phase ahead of the TBM does not get collapsed. Hyperbaric intervention is a very special situation. It's not normal use. In normal condition, if it is a hard rock condition or if it is a very stable ground condition, mostly you are using compressed air condition. So hyperbaric intervention is only used where you need a very high phase pressure, or you are encountering that very high water ingress through the TBM. So there we are using the hyperbaric intervention condition. And this intervention depends on the type of the ground. So if it is a soil type of ground, your intervention will not be very frequent. It can be at 200 meter, 250 meter. If it is a very hard rock condition, it can be at every 50, 60 meters. So depending on the type of the ground, depending on the type of the rock, depending on the compressive nature of the rock, depending on your penetration rate of the cutter head, and depending also all these properties, you have to decide where you have to take an intervention. So during the intervention, you have to park the TBM. So TBM will be stopped. So if you are working, if you are parked the TBM below a very dense residential or dense populated area, there are lots of structure. You have to ensure certain type of precautionary measures so that the phase pressure is maintained and there is no ground settlement, and the structures lying above the ground are very stable. So mostly we try to do this intervention in an open type of ground. We do not do intervention in a deep residential area, or we do not do the intervention where there is a very soft ground condition. So intervention is a planned intervention, but there are certain situations where we are also doing an unplanned intervention, because might be I need a intervention because my TBM is getting stuck, or my TBM operation is not able to, I am not able to move. So we do a unplanned intervention. So it can be a planned intervention, it can be an unplanned intervention. So this is the full of the TBM basics, and this is the mostly the references we are using for the TBM operation, for the selection of the machine, for the performance of the machine, and what type of different type of machines you are using, which machine is suitable for which. So this is the most of the reference. So I will stop my uh, lecture here, because the next 25th, next Saturday, we'll discuss on the TBM segment design, because I want that first of all you study the TBM basics part, and you have any question, we'll discuss within this next week. and the next week we'll discuss on the TBM segment part. Because whoever not work in the TBM, he has to understand the TBM basic operation part, because the precast segment design, it's a structural design, but it's mostly related to the TBM movement part, or how the TBM is working. It is very closely related. Okay. So anyone have any question till here?
Have we used hyperbaric intervention in Indian projects?
We use, but it depends on. It depends, as I told you earlier. Hyperbaric intervention in Ahmedabad Metro we have used in one of the stage, because that space the ground was very soft, very soft. The clay, it was a very highly compressible clay, and we had a very high water ingress. And in one of the scenario, we have done the intervention directly under a charge. So you can understand that we have to make a very controlled condition, unless there will be a movement of the ground and the building structure will get affected. But there was a serious incident still happened. We could not control the phase pressure, because during the intervention there was a heavy rain and some part of the surface ground collapsed, and the TBM could not maintain the phase pressure. So the TBM itself also got stuck. So hyperbaric intervention, this was a very interesting question asked in Dubai Metro by one of my colleague. He asked about this hyperbaric intervention. But since in Dubai or in Riyadh we have sandstone, we do not have a very soft ground condition. We have sandstone, and the groundwater is also very low. If you work in Saudi, if you work in Middle East regions, we do not encounter very high water groundwater scenario. So there we do not need hyperbaric intervention. Also, it depends on that whatever the groundwater you have, what is the groundwater pressure? If the groundwater pressure is very high, so how much bar the pressure it is applying on the TBM phase? So that is also very important. Hyperbaric intervention is a very controlled intervention. It has to be done very precisely. In suppose if you work in Lucknow, we never did hyperbaric intervention, because the groundwater table is 25-30 meter below the ground. It's a very self-supporting ground. It has very high cohesion properties, very high shear strength properties. So the even ground itself is stable. We do not need a very high phase pressure. So you need to study what amount of phase pressure you are applying to the TBM during the TBM movement. What is your groundwater condition? That is it a seepage? If it is a gushing water, if it is a moderate water condition, and what is your shear strength of the ground? So accordingly, you need to decide that whether I need to go with an open mode intervention, whether I need to go to hyperbaric intervention, whether I need to apply a minimum air pressure. Because during the intervention also you need to apply a phase pressure. Uh, Another thing I want to mention, that TBM phase pressure is a very important, that is to be decided during the TBM operation. It is jointly done by the designer and also the TBM crew and the contractor. The phase pressure, it's the pressure that the EPB machine, or you can take the slurry machine, it is applied to keep the phase stable. That is the ground ahead of the TBM stable. Now the phase pressure, it can vary. It is not along the stretch, it is constant. It depends on what type of ground I am encountering, what is the ground pressure, what is the water pressure, and what is the cover above the TBM. So if the cover above the TBM crown, that is the TBM crown, the cover is less than 1D or less than 0.5D or mostly close to 1D, and you have lots of structures. So if you apply a very high phase pressure, then you get a bulging of the ground. So sometimes you see that there are lots of bulging of the ground, lots of cracks coming in the ground, or the ground is blown, or sometimes you are getting a cracks in the buildings. So mostly that is the phase pressure is not, you are not able to control. It's not possible that you can control, because depending on the ground scenario, at that scenario you cannot, it might not be able to control the phase pressure. But when you are doing a intervention, you have to maintain a minimum phase pressure to keep the phase stable when you are working, because the TBM, when you are working, it's not in a fully pressurized condition. So to maintain the pressure, you have to apply a phase pressure. So that is why either we maintain a minimum air pressure. So it can be 10 bar, 20 bar pressure you are applying. Anyone have any other question?
Yeah, in addition to that, just what you explained, how to calculate the phase pressure, and do we need to use any software to do it?
This is a phase pressure. Actually, the designer they apply is a called Angst method. But that is a very complicated method. It's a wedge method that you are assuming there is a wedge ahead of the TBM phase, and that wedge, it's a three-dimensional wedge, and what is the amount of the thrust it is applying. So it is a complex mechanism. It is taking into account of the ground shear strength. It is taking into account of your water condition, so that you can get a phase pressure. So what we do as a designer, we along the TBM stretch or along the tunneling stretch, at every 20 meter or every 25 meter, we specify the phase pressure. And taking in this into account of this phase pressure, whatever the designer has provided, the contractor, they calculate their own, they have their own calculations or they have their own methodology. They compare this phase pressure. Suppose in a certain stage, I have given a 50 kilopascal pressure, suppose zero 0.5 bar pressure. But the contractor thinks that my TBM in that stage, it is a park. So I don't have any structures. So even some part of the ground gets disturbed, it will not be a very big problem. It can be managed. But if it is a some sensitive structures is lying, so you can see the TBM is passing in a certain region where 250, 300 buildings are there, and the ground is not competent. So there, I cannot apply a very high phase pressure. I have to apply a minimum phase pressure to keep my phase stable. Because if I apply a very high pressure, that might affect the foundation of the building. So the phase pressure application also depends on your type of the ground as well as the cover above the ground and what type of structures that is lying above the ground. What is your penetration rate? There are lots of things that takes into account when the phase pressure is being applied. But the process starts from the designer. Designer gives an idea about the phase pressure as per the ground condition. But from the operation point of view, the contractor decides finally what amount of phase pressure he will apply. So whenever you are working in a TBM project, every day you will get a TBM monitoring chart. In the TBM monitoring chart, you will get all the TBM operational parameters. There is a standard sheet that is provided by the TBM team to the designers. In the chart, you will get what amount of thrust he has applied, what amount of torque he has applied, what amount of phase pressure he has applied, what amount of mark he has removed, what is the specific gravity of the mark, what amount of rings he has built, and what are the operational problems he has encountered, what is the ring building scenario, everything you can get. And so from there, if you monitor the operation, you can get an idea that what is the deviation, what amount of the thrust you have specified, what is the deviation, what amount of torque you have the deviation, approximately what is the progress, what amount of phase pressure, everything you can compare. So apart from the design, if you monitor the TBM operation as a designer, you can get a very good idea that how the overall operation is being compatible with your design.
Also, I believe overburden pressure, because alignment is not going at the same depth of, it maybe varies, like
So that
maybe.
yeah, so that is why suppose I give you an example. In a 500-meter stretch in one project, we applied a very low phase pressure because we had lots of buildings and the buildings are very old. Some buildings were also jhopdis. It is not a uh, reinforced structure. It's just a load-bearing wall, some big structures, some small huts. So that portion we did not apply very high phase pressure. When you cross that 500-meter region, after that we got a 200, 300-meter stretch where we had the open ground or park, very huge park or very open land. So there we have applied a high phase pressure and we have made the TVM progress faster. So there, in the initial 500-meter stretch, we have applied a phase pressure 50 kPa, 60 kPa, so zero 0.5 bar, 0.6 bar. And then when we got a very high overburden, or there is open ground, we don't have any structure, and the ground is also competent, we have applied a phase pressure of 1.5 bar, 2 bar, and then we have made the TVM progress faster. So both depends on your groundwater scenario and also your operational issues also. So TBM, that is why it's basically not purely design. Some things, some matters are also decided on respect of operational part also. This is quite different from a conventional tunneling. The conventional tunneling fully depends on your design or your design calibration. But in TBM, you don't have any chances to do calibration once the TBM is moving. So everything, whatever the design is done, it is frozen. Now, when the TBM is moving, The design has very low, very small role. The most of the role comes in the operational part. So if you have very good experience in TBM as a designer, or if you have worked in several TBM projects, you can get very valuable inputs to the TBM operational team or the contractor team when it is moving. So that is why when the TBM is moving, sometimes they take the designer representative in the site and keep them as a advisor when the TBM is moving.
Okay, thank you.
Okay, any other question?
Sir, I have one question.
Please.
In most of the metro project, we see the minimum curvature of 200 mm, 200
Yes,
meter minimum curvature.
yes,
But
yes.
suppose we are encountering horizontal and vertical curve and the same time. So how will compensate these two? How will calculate these two effects?
That is the articulation I told you. No, the articulation is basically taking care of the curvature part. So
No,
in
sir,
one of the project we got. Mhm,
so that is not my question. Suppose we are
mhm,
encountering a horizontal curve of 300 meter and
mhm,
as well as a vertical curve.
mhm.
So any way of to doing what is the equivalent horizontal curve or like that? Any
That is not related to your design part. That will be taken care by the whatever the curvature part of the TBM because it is basically the how they will manage the curve in the operation. So that is not part of my design. But I once the TBM segments has been installed, I as per the legal survey, I need to check that whether the segments has not gone out of tolerance. Only that part I have to check.
no.
Is it
Sir,
clear?
in the
Yes, sir.
Because if the curvature part in the operation, I cannot do anything as a designer. But once the segments has been installed, so in that particular curvature part, I need to see that whether the segment circle that is not gone out of tolerance because that is the main thing I need to check
Okay. Okay.
because I have designed my segment. I have given my segment tolerance. So I have the segment means the circle tolerance I have given. Now TBM itself has an insult tolerance. So inside the curve, it is also having a tolerance in the alignment. So everything that has been decided. Now once the TBM segments has been installed, everything operation has been done. So I get the legal survey data. So ring by ring, every ring as per the alignment, I will check that whether the circle is perfectly fitting. Sometimes the circle becomes elliptical also because it can be that one side has been get some thrust, so it has become elliptical shape also. So this I have to compare with that tolerance every segment by segment, and I have to make a comparison chart, and then I will decide that which segments has gone out of deviation. So the deviated segments I need to do some additional precautions to make the segment durable, or in terms of design life for durability, I have to make. Yes,
Okay.
please. Yes, please. The next question.
yes, sir. Sir, in the articulation, the extra excavation which we are doing,
Mhm.
is it going to be in the same direction of the alignment or is it going to be sidewise? And if
It is
it
to
is,
be no. It is flexible. If it is a curve alignment, it depends on how the alignment is moving. Actually, accordingly, the articulation is being done. So the articulation. So that is why nowadays the articulation system mostly follows the curve. Previously, what was happening? The articulation system there was a difference between the shield movement and the jack movement. So the shield and the jacks they are not following the perfect curve. So sometimes there was a difference. Nowadays they are mostly following the curve pattern. It is preferable that the shield and the segments they follow mostly the curve pattern. So that is why you are always using as a universal ring. So both side taper means that it is always try to follow the curve pattern of the alignment. So the shield and the segments they're almost in the same line.
so basically they don't have any extra excavation at the sidewise.
It depends on sometimes in a very tight curve we are using copy cutters, but copy cutter is a very specialized system. As I told you, the TBM, the features that comes, no, it depends. There are lots of factors that needs to be that does not come as built inbuilt. So you have to install additional features if you think. So if it is a very tight curve, so in one of the project we got a curve of 250 meter radius. So in that 250 meter radius, what happened? It was around 2018. So that 7 8 years ago, the TBM was not so much advanced that the tail shield got stuck. And when we tried to retrieve the tail shield, even with the articulation system, we were not able to retrieve. So we applied the thrust. So TBM shield was retrieved, but what happened? It affected the segment that was lying behind the shield, and we got a series of cracks in the TBM crown. So the cracks that appeared in the segment, it was not the design fault. It was because of the curvature, the TBM heel could not tackle the curve. And also the segment that is being built behind the shield, they are also getting stuck.
Got it, sir.
But articulation, there is a nowadays the active articulation system. We are trying to manage all the curves, but it is not perfect. As I told you earlier, that sometimes the curves or because the TBM itself it's a 20-meter length machine, so it's not possible that it's a power steering that you just rotate the car. And also
Yes.
there might be certain that one side you have a very limited area, or one side you have a very limited space to, because it has to move perfectly. So the 20-meter machine, it has to be moved perfectly in a very tight curve. It is very difficult. You can understand the scenario. So
Sir,
that is why the now
so that extra excavated part, is it filled just after the casting of the segment, or is it
yes
just
yes
left
yes yes
and
no. After casting of the segment, we are filling with the grout or pea gravel. So that is that filling of the primary grouting we are doing first. That is if you are making over excavation, and if the ground is very soft, no, you will encounter a high volume load. So the excavation
yes?
part and the strength of the ground has a very important role in the volume loss.
Okay, sir.
Okay. Anyone have any other question? Anything? Any doubt you have? Anything doubt?
Sir, when
Mhm.
we are
Mm.
doing that regal check,
Yes, yes.
when I went to the site visit, they told
Mm.
if
Mm. Mm.
the tolerance,
Yes, yes,
if
yes.
the segments were aligned
Mm. Yes,
and the
yes.
tolerances were met, matlab if it is 100 mm,
Mm.
if the tolerance is within that 100 mm, it is okay. But
Right.
what if that segment ring that we have arranged gone out of the tolerance? What do we do? Because we can't
That is
change that.
yeah. That is a very interesting question. If you have, suppose you have 200 rings, and the 200 ring you find that 10 rings have gone out of tolerance.
Hmm.
So if the 10 ring has got out of tolerance, we cannot rectify the rings because we cannot replace the rings. Because if I try to replace the ring, the ground will collapse. It will start moving, and it will affect the other segment. It will affect the surface also. So what we do, we try to check the stepping process. Sometimes due to out of tolerance, it can be stepping. Stepping means that the between the two segment you find a offset. So the offset also has certain amount of tolerance. So it can be 5 mm, it can be 6 mm, it can be 10 mm. If the offset of the stepping process, if the out of tolerance is too much, then what we do at the junction of the two segments, we do some additional grouting, or we do some epoxy filling also, so that the at the junction it is waterproof. So because our main purpose is the segment should be a watertight structure. So 100 years if I consider, so it should be watertight as well as it should be a durable structure. So if the segments has gone out of tolerance, then the designer instructs the contractor to submit a method statement on the rectification of the segment. So the method statement, the rectification means he makes some additional grouting through the segment, either through the grout holes, or he tries to make additional holes, or he makes grouting at the interface of the segments. and whatever the gap is there, he makes it watertight by epoxy grouting. If you are interested, I can supply you we prepared for one of the project that some segments we found they have gone out of tolerance. So we prepared a separate design methodology how to rectify this segment. Even we can see that some segments are getting cracks also, and these cracks are out of tolerance sometimes because our all segments has a crack limit of 0.25 mm. So it can happen that the segment has gone more than 0.25 mm. So what will be the rectification process? So these all things are done after the legal survey has been completed and the legal survey has been checked by the designer. Then the designer decides what will be the rectification measures to make it as a durable structure for 100 years.
So even the segments are cracked, we can't do anything directly. Only we can do
No. You have to seal the cracks. You cannot replace the cracks. You cannot replace the segment. Even one of the project, our segment got settled in one of the in Lucknow Metro, one of the station in Husainganj station. When the TBM was trying to enter the station and get retrieved, around 10-15 segments suddenly got settled. So the segment, if you think of the alignment in the horizontal alignment, 10-15 segments were out of the alignment. So they got settled. And because of the below the segment, the ground was too sharp that it cannot bear the weight of the segment. So initially it was we tried to raise the segments or to lift the segments by some pushing by jack. But then we found that we did not able because after behind the segments, all the other segments they are getting cracked or they are getting distorted. So what we did some grouting to push the segment. There is a grout called PU grout. The PU grout is a very flowing type of grout. It easily flows. It easily it is a very high consistency and it has a very high penetration rate through the ground and it applies a pressure and through this pressure we try to leave the segment as much as possible. And after that we have done additional grouting to close all the joints between the segments. This is a very typical case in Lucknow Metro. At the end, we did the segment that was settled. We try to leave the segment by doing a PU grouting to the segments from the bottom. And after the minimum amount it was lifted, then we made additional grouting to all the junctions of the segment through the segment by drilling additional grout hole. And then we made it as a watertight structure.
but it will affect the clear diameter. We can't do anything for
It
that.
will affect the clear diameter. That is what is done. That is when the railway contractor will come, because when the railway line will be installed, when the track will be installed, when the BLT contractor will come, that is discussed with the civil contractor and they try to manage there. Basically, what happens once the segment is getting deviated out of the curve, out of the element, we cannot rectify the segment or we cannot redo the alignment. So what we do, we try to adjust. If the deviated part is very close to the station, so we try to adjust with the station alignment. If it is mid of the station and the tunnel, we try to adjust in the track part because the track also has their own tolerance. So we try to see if it is adjusted in the BLT track or not. It's a very interesting case because there are lots of things I have done for this project, that how it is being adjusted finally after the legal survey data.
Okay, thank you.
Okay. Anyone have any question further? Okay, the next 25th, we'll start with the next and the final topic of the segment design. So I will share this final presentation and the recording. And if you have any question, please share with me and I will answer every question. Okay, in the video. Okay. Thank you very much for attending and for your
Thank
time
you.
also. Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Bye.